Welcome to today's class on process scheduling in operating systems. We'll explore how the OS manages process execution, types of scheduling, key algorithms, and how they enhance performance and multitasking. Process scheduling in operating systems manages the order and allocation of CPU time to processes to optimize performance and ensure fairness. It ensures efficient CPU utilization, reduces idle time, and enables multitasking. Scheduling decisions are crucial for balancing system throughput, response time, and process waiting time. There are two main types of scheduling: preemptive and non-preemptive. Preemptive scheduling interrupts a running process to allocate the CPU to another, often higher priority, process. Non-preemptive scheduling allows a process to run until it completes or blocks. Key algorithms include first-come, first-served, FCFS, which schedules processes in arrival order but may lead to the convoy effect. Shortest job next, SJN, which selects the shortest process but can cause starvation. Round robin, RR, where processes are assigned equal time slices, and priority scheduling, which uses process priorities to determine the next execution. Efficient scheduling is essential for system stability, responsiveness, and optimal resource utilization in modern operating systems. The CPU I/O cycle in an operating system refers to the alternating phases of CPU and I/O operations during process execution. Processes typically perform computations, CPU burst, and then request I/O operations, I/O burst. CPU-bound processes have longer CPU bursts, while I/O-bound processes spend more time on I/O. Efficient management of this cycle ensures optimal CPU utilization. Modern OS use multi-programming to overlap CPU and I/O bursts across multiple processes, reducing idle time and improving system performance. CPU I/O bursts in operating systems represent the alternating periods of CPU computation and I/O operations during process execution. A CPU burst is when a process performs computations, while an I/O burst occurs during input/output operations. CPU-bound processes have longer CPU bursts, while I/O-bound processes have more frequent I/O bursts. Understanding these bursts helps in efficient scheduling, as algorithms like round-robin and shortest job next optimize performance by balancing CPU and I/O utilization effectively. Scheduling criteria in an operating system are metrics used to evaluate and choose scheduling algorithms. Key criteria include CPU utilization, maximizes CPU usage to prevent idle time. Throughput, measures the number of processes completed per time unit. Turnaround time, total time taken from process submission to completion. Waiting time, time a process spends in the ready queue waiting for CPU. Response time, time between process submission and the first response. Efficient algorithms aim to minimize waiting, turnaround, and response times while maximizing throughput and CPU utilization. Balancing these criteria ensures optimal system performance and user experience. Optimization criteria in an operating system are used to improve scheduling and resource management. Key criteria include maximize CPU utilization, ensure the CPU is busy as much as possible. Maximize throughput, increase the number of completed processes per unit time. Minimize turnaround time, reduce the time from process submission to completion. Minimize waiting and Response time. Ensure quicker process execution and interactivity. Balancing these factors ensures system efficiency and fairness. Scheduling in operating systems is classified into three main types. Long-term scheduling determines which processes are admitted to the ready queue from the job pool. It controls the system's degree of multi-programming. Medium-term scheduling temporarily removes processes from memory, swapping, to manage resources and improve performance. Short-term scheduling selects processes from the ready queue for CPU allocation. It is frequent and critical for system responsiveness. These types work together to ensure efficient process management. The classification of scheduling activity in an operating system is based on process management at different stages. Long-term scheduling manages the admission of processes to the system. RIT controls the degree of multi-programming by deciding which processes enter the ready queue. Medium-term scheduling temporarily removes or swaps out processes to reduce memory load and improve resource allocation, enabling better CPU utilization. Short-term scheduling, also called CPU scheduling, it selects processes from the ready queue for execution. This occurs frequently to maximize responsiveness. I/O scheduling manages I/O devices by determining the order of I/O requests to optimize performance and minimize waiting time. These activities collectively enhance system efficiency and responsiveness.